Hello class, welcome to Windows Server Administration. This is week 1, chapter 1 of the spring semester. So right now I have Blackboard open. I just figured we could walk through Blackboard just so in case you guys are not familiar with it. So here, this is the announcement page. This is exactly how you guys are going to see it, the student view. So we have the most up-to-date announcement that I put, I think it was like 2 days ago. Basically just saying when the homework is due, which is the 29th for the first week. To go over the syllabus, if you haven't done so already. We're going to go over it today as well in this video. And I think I also said there's chapter readings, and then also there's another announcement prior to that that I had posted a week ago. You could read that as well. It's kind of the same stuff. Also, discussion board posts, like your self-introduction, just so I could kind of get to know you guys a little past just being students, because everyone, you know, has their own life. So just so I have a better idea of like who my students, what they have to juggle aside from just schoolwork. So that's the announcement section. So under course outline, you'll find the syllabus, and you'll also find a resource policy and procedures form, which is given by Tunxus. They wanted the professors to make it available to you guys, so I placed it there. We're going to go over the syllabus in a second. So we have the course content folder under week 1. That's all there really is right now. Okay. So week 1, we have the PowerPoint presentation. We're gonna briefly go over it in this video. It's pretty long. The chapter is kind of long, but it's just like a lot of terminology in the chapter for chapter 1. I recommend you guys read it. So under chapter readings, you guys can read the entirety of chapter 1 right there. We have homework assignments. We have 2 homework assignments. One's a prereq, just so you guys can get familiar with the virtual lab, and then the second one is a installing Windows 2019 lab. We're gonna kind of try to go over it this class just so you guys can see how it's done. And then we have the discussion board tab, and if you guys could just post something there when you guys get a chance. And that's Blackboard. So let's go to the syllabus. Close Blackboard. Okay. So the syllabus. Windows Server Administration. There's a couple prereqs to the course, but you guys already have that. My contact info. So if you guys have any questions about homeworks, exams, or just general questions that you might not understand from a certain chapter, like after you read it, just feel free to shoot me an email and I'll get back to you as soon as I can, like 24 hours-ish. So I also don't have official office hours, but I am open to scheduling a meeting with you via WebEx or in person if they allow me to. The in-person, I say that because of the whole COVID thing, but yeah, we can schedule a meeting if the question can't be resolved via email. I am open to that. Then we have the course description, student outcomes, just general stuff. We have the textbook. So we are using the MindTap version. So in addition to the virtual or physical textbook that you guys purchase, make sure you get the access code to MindTap, because a lot of the homework assignments are going to be in MindTap. So there's that. We got the grading breakdown. I do place a big emphasis on homework, which is why the weight is 40%. So just try to get your homeworks in, or submit your homeworks in, or on time, or if you have to submit it late, it's fine. There is a late policy in here. We do have 3 tests, each are 20%, and then we have the grading scale. As for academic integrity, just try to do your own work. Don't copy other people. If I suspect you guys are copying, then we have some steps that will be taken. You guys can read through that. Attendance, it's a fully online class, so attendance really just means logging into Blackboard, doing your work, doing your readings, and you should be good. As for makeup policies like late homework assignments, missed exams, you guys can read through that. It's not too complicated. As for the course schedule, I kind of broke it down by week. So week 1, you guys, I just assigned read chapter 1. We're basically just going over chapter 1 for week 1. And then, like I said, the Prereq lab, and then the installation of Windows Server lab. And then we have due dates right here. So week 1's homework will be due on the 29th. And that's pretty much the syllabus. Let's go to the PowerPoint. Yeah. So like I said, it's a super long PowerPoint because I just kind of went through the chapter, found stuff that I thought were either terminology that will probably be put on the test, depending, or important stuff that is relevant to actual management or installation of Windows Server. So that's why it's pretty long. Don't get intimidated by it. It's not that insane of a concept to understand. So I'm gonna kind of like breeze through it. I'm not gonna go over each slide in depth. So the Windows overview. Windows Server plays a critical role in a lot of organizations, small or large. Windows 2019 is Microsoft's newest server platform, and it offers more features than previous versions of Windows Server. It's kind of like a history of Windows right here. The first Windows operating system was introduced in 1981. Then we kind of go into the 90s here with the rise of computer networks, which resulted in organizations needing to moving towards using computers to share resources. Continuation. So a PC connecting to a shared resource is called a client, and the computer that is the one sharing the resource is called a server, at its most basic form. While any operating system can function as a server if it shares resources, specialized OS systems are geared toward resource sharing and have since been commonplace since the 90s. And then we mentioned Microsoft released its own version of Windows Server OS back in 1993. So current day. By 2000, Windows NT Server was renamed Windows Server, and in 2018, Windows Server OSs were installed in over 80% of all servers worldwide. And then we kind of have like a graph right here of the market share of operating systems. So servers. Servers are located within organizations. These are called on-premise servers or on-site servers, meaning like they're either physical or physical servers that host virtual servers. As long as there's a physical host on site, it's an on-premise server. However, with cloud computing, many servers nowadays exist within data servers outside of the organization. These are called cloud servers, and the collection of all these cloud servers is called the cloud. Then we move into rack mount servers. So these servers differ from that of a desktop PC in the hardware that is within these servers. These servers are typically placed within a rack mount case like the photo shows. They're usually stacked, and then you have to like screw them in. So when a server is mounted alongside other servers on a vertical server storage rack, the servers are referred to as a rack mount server or servers. The servers within a rack mount server do not necessarily run all the same OS. They can have different OSs. One could be like a Linux server, the other could be Windows. But regardless of the server or the OS running on each individual server, there's typically a monitor, keyboard, and mouse connected to the rack mount so that admins can not only go through the installation of the server, like the initial configs, but also troubleshoot the server if they can't do so remotely. Additional rack mount components. This basically is just kind of telling us what else is usually stored in the rack mount. So we have storage area network or SAN devices that are usually placed there. A couple UPS systems that are basically used in case there's like a power outage, just so that the servers don't completely shut down and they can maintain power just for a little bit. So now we're going to go into 1U versus 2U servers. So a 1U server has a minimum height of 1.75 inches. These servers usually have two hard drive or SSD typo SSD slots in them, and two processors. Now a 2U server is twice the height of a 1U server, meaning it takes two spots in the rack mount compared to the 1U, and they usually contain up to 4 processors and 8 hard drives or SSDs. Whoops. So server design. So this is kind of what I meant. So in the photo you can see that the web server, file server, and firewall server are 1U versions, meaning like they're only taking up one slot in the rack mount. And then you have the database server, the email server, those are 2U, even the UPS. And then we have the SAN server down here, which is a 4U, meaning it's taking up the space of 4 of these web servers. And then we have the management system. So that's just kind of what this diagram's showing. And this is kind of just additional notes. You guys can read through that. Virtualization. So it's the process of running more one operating system on, at the same time on one single computer. And then usually you need software that allows the hardware to host multiple OSs, which is called typically called the hypervisor. So hypervisor. So the Type 2 hypervisors are designed to run on top of an existing workstation operating system. And Type 2 hypervisors are used today for software testing and development. So an example of a Type 2 hypervisor would be like a VMware Workstation, Oracle VirtualBox, and Parallels Workstation. Not necessarily Microsoft Hyper-V. We're going to see why a little bit later on. So server application software. So by the mid-2000s, most server closet data centers contained many individual rack mount servers. But for security purposes, each rack mount server ran only one separate software application, whether it was web server software, file sharing. The issue here was that the server software application only utilized a small fraction of the rack mount server's hardware and supplying power, and it was really inefficient to do so. So the solution to this was server virtualization, but with a Type 1 hypervisor to ensure that each virtual machine ran as efficiently as possible. A Type 1 hypervisor interacts with the hardware directly and contains a small operating system to manage the hypervisor configuration in virtual machines. An example of a Type 1 hypervisor would be Microsoft Hyper-V and VMware ESX. And then we got some additional information on hypervisor right here. You guys can read through that. Virtual hard disk provisioning. So virtual hard disk provisioning is when you allocate space for the virtual hard disk file, and you are given two choices when you do this. You have the fixed space or the dynamic allocation of space. When you give a fixed space for the virtual hard disk file, this is called thick provisioning, and when you dynamically allocate space, it's called thin provisioning. And then here we got file extensions for virtual hard disks. It varies by vendor. You guys can see them right here. So checkpoint feature, another feature of Hyper-V is that it allows you to create checkpoints or snapshots. A checkpoint of a virtual machine creates a second virtual hard disk file that you can go back to if you're making a big change to the OS and things go wrong. You could always go back to the checkpoint that you create. That's kind of why it's there. So consolidation using hypervisor. Most servers today that run a hypervisor in virtual machines are 1U, allowing the rack to accommodate more rack mount servers in the same place. Basically saving space on the rack mount, that's the point. So nested virtualization, unlike most hypervisors used today, Hyper-V allows you to run other virtual machines within an existing virtual machine. It's called nested virtualization. For nested virtualization to work, both management operating systems must run either Windows 10, Server 2016, or Server 2019. And we got a little bit more information right there. So Windows containers. So unlike virtual machines, containers do not have a complete operating system. A container is a subset of an operating system composed of one or more web apps, and the supporting operating system files needed by those web apps only. Containers must be run on an existing operating system that has a container software already installed on it. So container execution. When you run a container, web apps are executed in a way that is isolated from web apps running within other containers. So this is called sandboxing. To allow each web app to be uniquely identified on a network, each container functions as a virtual operating system with its own unique name and IP address. And then you might be asking, like, okay, so what's the difference between containers or virtual machines? So while you could use a virtual machine to run individual web apps on the same computer in the same isolated fashion that a container would provide, the use of a container uses far fewer underlying system resources. So it's just more efficient and more scalable for a company. And then here's some container software options. So the kernel. The core component of an operating system that executes all other components of the operating system is called the kernel. Containers do not have kernels. They rely on the underlying operating system that runs the container software to provide the kernel. Due to the reliance of a container to the underlying operating system's kernel, it presents a single point of failure. So if the kernel, if one container is, if multiple containers are using the same kernel, it could definitely slow down system performance. So Hyper-V solves this issue because Hyper-V can be used alongside containers to provide a separate copy of the underlying kernel to each container. That way they're not all going to the same one. And we got some Windows 2019 features. So workgroups. When you set up a Windows client or server, it becomes a part of a logical grouping of computers. This is called a workgroup. Workgroups use peer-to-peer networking, allowing computers on that same network to share resources with one another. The only issue is that in order to access another user's resources, you would need a valid username and password. of a user that has access to that specific resource. So that can be a complicated way of managing resources. And also, downside to work groups is that each user within a work group is responsible for the security of their own resources. And since not all users are necessarily security minded, this can present a security issue within a company, which is why we use domains. So to coordinate resource access, users, and security on networks today, each client computer and server or servers on the network would join a domain instead of a work group. A domain is a logical group of computers that authenticate to a central database of users stored on special servers called domain controllers. So when users log into a domain-controlled computer, their credentials are authenticated by the nearest domain controller on that network. And these domain controllers maintain a central database of users and passwords. And then we have SSO, which is single sign-on. So this basically is like once a user's credentials are authenticated by a domain controller, that user is given a token by the domain controller, which allows them to authenticate with the network automatically whenever they access any other server or clients on that same domain. So Active Directory. So the software components that provide for this functionality are collectively called Active Directory. Windows Server can be easily configured as an AD domain controller to provide SSO for all other computers joined to a domain. SSO or AD also contains many other services and components that can be used to essentially manage and secure computers joined on a domain. Then we have group policy. So whenever a computer joins a domain, the user is essentially giving up admin rights of that computer to the IT admin of that domain he or she joined. Group policy is a tool used by IT admins to configure groups of computers on a domain. It can be used to configure OS settings, security, and software for different computers and users in that domain. And so security in Windows Server 2019, it's more secure than previous server versions. They've added, whenever you add a feature or install a Windows component, an essential level of security is automatically implemented. This is done so no backdoors are left open for an attacker to leverage. Malware protection is also another feature of Server 2019. And Microsoft Defender monitors the server for malware to automatically stop processes that are known to be dangerous. And then on top of Microsoft Defender, there's also Microsoft Defender ATP, which if installed, then any processes or files that are known to be dangerous, like zero-day attacks or rootkits, like stuff that is suspicious but not necessarily defined, will be sent to servers within Microsoft Azure for deeper inspection. And then they use deep learning and sandboxing techniques to determine if a process or file is like a new type of malware, and then they'll update all ATP on all Server 2019 systems worldwide with whatever they find, if it is malicious. So here we have some additional security features like BitLocker, shielded virtual machine, and you guys can read through that. Got basic security features in 2019. So file system features. So Windows Server 2019 supports NTFS and REFS. NTFS is built-in support for file and folder permissions, compression, EFS encryption for individual files and folders, etc. It supports data duplication, which saves space by allowing duplicate files on a volume to be stored once on the physical storage server or storage device. You can create NTFS large disk volumes of up to 8 PB, which is an upgrade from 2016, which was only 256 terabytes. NTFS login, so this is really good. So it's like NTFS uses a journaling file system, meaning it tracks changes to files and keeps a record of all those changes in a separate log file. This could be good for retrieving documents that were deleted by accident, or in case a computer crashes or loses power, the log file will show why that happened. NTFS is self-healing, meaning the NTFS volumes will self-heal themselves. In the case that software damages a disk area, NTFS will heal that area without having to take the server down. Got file system cache. So NTFS also works in a virtualized environment due to the way it interacts with a file system cache. A file system cache is an area designated in physical computer memory that is used in Windows operating systems to help speed up reading and writing to hard disk. The size of the allocated cache for NTFS operations directly affects the speed of writing and reading, which in turn affects user wait time for the server to respond to their requests. Got some additional stuff right here about file systems. So REFS, first offered on Windows Server 2012. It's still regarded as a file system that's in development. It excels over NTFS when it comes to storage spaces. And storage spaces are a feature that allows you to build large fault-tolerant volumes that span multiple physical storage devices. And then the third version of REFS was introduced in Server 2019. Data duplication. Server 2016 introduced the ability to replicate data between two servers seamlessly. This is called storage replicas. And Microsoft released a new storage migration service in Server 2019. So, privileged mode and protected processes. So, the Windows kernel runs in privileged mode, which prevents it from problems created by malfunctioning program or processes. A process is a computer program or portion of a program that is currently running. A large program might start several smaller programs or processes, and a protected process cannot be influenced by a user or other processes on the system. An example of a protected process might be when the computer performs its own system maintenance or updates a database. Multitasking multithreading. So Server 2019 takes full advantage of the multitasking and multithreading capabilities of modern computers. Multitasking is the ability to run two or more programs at the same time, while multithreading is the capability of programs written to run several program code blocks at the same time. So multitasking in Server 2019 is called preemptive multitasking, which means each program runs in an area of memory separate from areas used by other programs. We got processor scalability, so this kind of just goes over the physical hardware. So if you have a physical processor plugged into the processor socket on with a physical processor, you would typically plug it into a processor socket on the motherboard of a computer. And Server 2019 can support up to 64 sockets for individual physical processors. A logical processor is housed within a physical processor, with each logical processor being referred to as a core, which runs its own executable threads, meaning a single physical processor, like say with 8 cores, would technically mean that it has the power of 8 processors in one physical processor. So Server 2019 supports an unlimited number of logical processors, allowing for scalability. and logical processors can also be used as virtual processors for virtual servers. We got server clustering. So clustering is the ability to increase the access to server resources and provide fail-safe services by linking two or more discrete computer systems. A server cluster can be configured to provide increased speed and fault tolerance, and configuring servers for fault tolerance with the sole purpose to only respond to users when the main server fails is called failover. Though server clusters are typically used for frequently accessed and mission critical services, such as databases. And here we got some administration tools: Server Manager, PowerShell, and Admin Center. So Server Manager, originally introduced in Server 2008, allows the admin to monitor and manage the configuration of the local server it is running on. So upon logging into Windows Server with admin privileges, Server Manager will open by default. Windows PowerShell, Microsoft's first OS, MS-DOS, didn't contain a user interface for users, so users had to enter in commands using a command line interface called a shell. This shell is still accessible today in the form of the command prompt. But unfortunately, the command prompt does not offer the same standardization, rich command set, or advanced scripting functionality that Unix or Linux shells offer. So Windows solved this problem with the introduction of Windows PowerShell in 2006. So commands within PowerShell are called CMDlets and have a action object structure. Nearly any task can be performed by these CMDlets within PowerShell. Some tasks that you might be required to do not necessarily have a graphical interface option, so you might be required to use PowerShell to be able to run commands to do certain tasks. It's a powerful scripting language, and most of its PowerShell scripts are saved as .ps1 files. So Windows Admin Center. So it's new to Server 2019. It's a web-based management tool. It's not installed by default, but can be downloaded and installed after server setup. So with this tool, an admin can use a web browser on any networked computer to connect to the Windows Admin Center. But it should be noted that not all Windows Server configuration tasks can be performed using the Windows Admin Center at this point in time. So small footprint installation options. So if you were to install Server 2019 with the bare minimum set of services, features, and functionality, this is called a small footprint server installation. It's typically done to lessen the areas of malicious users attempting to gain access to your server. Because of this, it has a smaller attack surface. And these installations also use, by default, less hardware resources on the server. So with a small footprint, we have the server core, because there's two installation options: server core and Nanoserver. So server core retains much of the core Windows Server OS, but removes the graphical frameworks and processes, meaning you would use PowerShell to do most of the configurations. Many Microsoft and third-party software packages cannot be installed on server core since they rely on graphical .NET components. So Nanoserver. So Nanoserver is even smaller in its footprint than server core. Without additional software, a base Nanoserver consumes less than 500 MB of disk space. Nanoserver does have fundamental elements such as .NET Framework, which it uses to develop and execute applications, but it has few other components. And then here we have 4 roles that a Nanoserver would typically cover. And then we have some additional facts about Nanoservers, but you guys can go over that. So hybrid server, or hybrid cloud. So 2019 offers more features to connect on-site servers to the Azure cloud. This is referred to as hybrid cloud. Features such as Azure Backup, which would back up information of on-premise servers to the Azure cloud. You got update management, Azure Update Management, which allows for central management of updates for on-premise computers and virtual machines running in Azure. And then you have Azure Site Recovery, which ensures key services that are run on-premise are made available in the Azure cloud in case of failure of on-premise servers. You got Linux application support. So most web apps that run in the cloud run with Linux containers. Windows solves this with its own WSL, which provides a Linux kernel interface for Linux apps that allows them to execute directly on Windows kernels within a Linux operating system environment. What this basically means is that you could run Linux containers on Windows Server 2019 alongside other Windows containers. So that's pretty useful. Windows Server 2019 editions. So Microsoft offers a lot of different versions of 2019, and they call these editions. Each edition has the same foundation of Server in 2019, but offers unique capabilities that can be tailored for a specific user or organization that will be using it. You got Essentials, you got Standard, Data Center, Storage Server 2019, and Hyper-V Server 2019. And then here we just got some minimum requirements that you're going to need for your system to be able to run Server 2019. Planning ahead. So you're going to want to leave yourself room for growth past those minimum requirements. And this will vary depending on the amount of users you have in your company or clients that'll be accessing the services on that specific server. So planning hardware for a specific server given its use within an organization is called capacity planning. Hardware should be planned based on server role and projected growth. This includes considering the number of processors, memory, storage options that best fit the corporation, whether it be small, medium, large. So obtaining installation media. This can be done in different ways. You can get a bootable DVD, a USB flash drive, or an ISO image. Starting installation process. So you want to point the computer to the installation media if you're doing this on a physical server. This will be done by accessing the BIOS of that physical server and changing the boot order of the physical device to your installation media. For virtual machines, you would just simply boot a new virtual machine from the iOS image file. Completing installation process. We're going to go over that in the lab walkthrough. It's pretty straightforward. And then post-installation config, which is like a to-do list that you typically want to do after you finish installing Windows Server. So you want to set the correct time and time zone, configure the IP on the server's network interfaces, configure the firewall, change default computer name and domain membership, install a web browser, and then activate your version of Windows Server. That's pretty much it. So that is the PowerPoint. So let's open up the lab. Get rid of this. That is not the lab. This is the lab. Okay. So this, let me go back. So let's do the lab prereq first. So you'll find this under the content folder of week 1. I believe it's titled homework. So active assessment. Okay. What is this? Done. No, not done. Next. Okay. So, you guys can read through this. It will take approximately 30 minutes to complete this lab. Click next. Lab topology. So it's basically telling us that we have a standalone server. We have two standalone servers. And in this lab, we're going to have access to both of them. So we have plabs A01 and plabs A02. And right now, plabs A01 is currently opening on its own. We got the server management window that opens up upon logging in that we learned from the PowerPoint. Notice the IP addresses. So it's going to be important. So I believe maybe write it down. They might show it to you later on. You could always check it too through, I believe it was, actually we could just open up CMD. So if we do ipconfig, if you're on the server itself, you could find the IP address this way. Open up a command prompt window, CMD, and then type in ipconfig. And here we can see that we have the 192.168.0.1 for plabs A01. Let's see what they're asking us to do in this step. Doesn't look like they're asking, they're just telling us. Okay. So, user interface. Step 1. From what I can tell, they want us to power on. Okay. I mean, it's really just familiarizing yourself with the environment. They want you to turn on both machines. They want you to turn them off. Just be familiar with what all of these little features do. So this exclamation point will give you the host name of the device you're on, the operating system, the admin credentials, the IP address, so you don't necessarily have to open up CMD. And then with the, I believe it's, okay. Oh, reconnect to device. Okay, switch to console, which would be, okay. Oh, with this menu, you could also type in the Control-Alt-Delete. So I'm just going to put in the password, which is, okay. So yeah, this doesn't look that insane. So it's really just familiarizing yourself with the environment, and then I believe it tells you to answer some questions as you go along, these checkpoint questions. And then when you're done, just press done. Doesn't look that that difficult. So I'm gonna press done. Gone to the end, and is there a submit? Perhaps I just click on the X. It may have submitted it for me. Yeah, I haven't submitted it yet. Oh no, it does say it's complete. Okay. So yeah, if you check here, it'll let you know if it's complete. But if you have any questions, just let me know. So we'll get out of this, we'll go to lab 1. So start assignment, and we'll see what lab 1 gives us. Start over, just yes. So do next. Okay. This is just the lab topology that we're going to be working in. We got the same 2 servers, and then we also have a domain number or domain member. Actually, no, we have the 2 domain members. We have a domain controller, a standalone server that's not a part of this domain, and then we have a domain PC. No steps here. We'll do next. Okay, so these are the actual steps. So step 1, connect to plab DMO1, which is this one. So we're going to power it on. It's the second one in the list. We'll just wait for that to go. It does take a second. And so for step 1, it's literally just connecting to the correct server, and then clicking the tools menu and select Hyper-V Manager. So once this powers on, I'll do that. So this is the server manager. This is the dashboard. You can click tools and do Hyper-V. Let's see if we could find it. Did I connect to the right one? I should have, yeah. So Hyper-V, perhaps I'm just blind. Let me check this one. Oh, you know what? I wasn't clicked on the right one, so make sure, even if you turn it on, you want to click on the correct server. That's why I didn't see it. We'll go to Tools, Hyper-V Manager. Okay, so step 2. The application's going to open. We're going to right click on plabs AO2, so right here, and connect to it. Press start. We're going to give it a second as it starts up. So step 5, because step 3 and 4 is just literally waiting for it to start up. Step 5 is configuring the Server 2019 installation. Okay, so when step 5 loads, okay. It also says we can maximize, there we go. Because now we're working in a virtual machine within plab DMO1. And then we can actually also maximize. Yes, okay. So we're going to go with the default here of English. Go next. We're on step 7 at the moment. We'll press install. We're going to wait for this to take a couple seconds while it sets up. And then once it does give us another screen, we're going to select the operating system we want to install. and we're going to do standard desktop experience 2019. Click next, and then the applicable notes and license page, we're going to accept that. Click the box, click next. We're going to click the second option of custom. We're going to allocate the space here and click next, and it should begin installing Windows. We're going to give it a couple of moments to do so, and once it finishes installing, it should automatically restart PLabs AO2, which is the virtual machine we're on at the moment. We'll just give it a couple of moments. And once this does finish installing, it should give us a black screen that says press any key to boot from CD or DVD. The instructions do say to ignore it, so we'll just ignore that and Windows should boot by itself. It does take some time to install. So it does look like it's going to take some time, but after it does finish installing, we should just have to set a password for it. It's going to default give you an administrator account just to use the password of password, but with the O as a 0. And then Windows should finish finalizing your settings. After that, we would log into the virtual server using that administrator account that we created with the password of password. And then it should allow you to log into it. And then it says at the end of that, just take a screenshot. And that's what you would, I believe, submit for step 3 or page 3 of the lab. So just like that, take a screenshot. Let me see what this dropdown says. Okay, so these are the action items that you would have to complete. So the second action item would come on page 4. So it's just like it's really just a bunch of little steps that it has you do, and then as you go, it'll give you that that notice to take a screenshot. You would just press that button. Let me try to find where the next screenshot is. Okay, it's at the very bottom. Okay. So there's 3 screenshots. So there's a screenshot on page 3, a screenshot on page 4, and a screenshot on page 5. And then the rest are just questions that you have to submit, or that you have to answer. So let's pretend we're taking a screenshot of this. Take a screenshot. Now we'll go to the 3rd screenshot. Now we'll go to the questions. Okay, so the questions are on page 6. It's basically kind of asking you about what you did throughout the lab. Just answer the questions. And there's 1, 2, 3. There's 5 questions, so not too difficult. And then once you do all of that, you would do submit report, and then I would get it. So, for example, just gonna randomly click on some of these. Submit. Okay, well, it tells you if it's incorrect, so that is good to know. So say, oh, it doesn't let you change your answer. Okay. Do this. Correct. And then you would do submit report. So because it doesn't allow you to change your answer once you submit your question, your individual question, I would make sure that you take some time to make sure that you're confident in your question, in your answer, because you don't get to resubmit that unless I'm not sure if it allows you to just destroy the lab and do it again, but I don't think it does. So you might only get one shot at it. So just try to be careful, try to think it through. Go through the lab again. If you're unsure of your answer, you have all these virtual machines that you can maneuver through and try to find that correct answer. And then once you're certain, press submit report, and then I would get it. So let's see how this is doing. It's still getting ready. So it does take some time. So when you are installing this Windows server on the virtual machine, maybe just step away for 5 minutes and it should be done by then. Just finished. But yeah, seems pretty straightforward. If you guys do have any questions, just let me know, and I will be happy to reply. Just send me an email with a question, and I believe, let's close this virtual machine. It's taking too long. And we'll close the environment. We'll turn it off. Let's turn it off. Close that. Close this. And that's that. Let's go back to Blackboard. So you'll find that lab under course content, week 1, homework assignments. So that's the second one. The first one was relatively straightforward. It's just getting familiar with any settings that you might want to adjust on those labs, whether it's text, whether it's opening or closing certain windows. It'll walk you through it in that lab prereq. Just make sure you get it done and then submit it. And then the second one, as you saw, it takes a little bit of time for those machines. They are a little bit slow, but fairly straightforward. I don't think you guys will have any issues with those, but if you do, just reach out. Also, make sure you do the discussion board. I do read those. I just kind of want to get to know you guys a little bit better, so that'll be helpful to if you guys can fill that out when you get a chance. And I think that is it for this week. I kind of went through the PowerPoint a little bit quicker because it was pretty long. Future PowerPoints may be shorter, they might be longer. We might spend a little bit more time on that. But as for the homework assignments, depending on the difficulty, so this first homework assignment was relatively easy. I didn't go through all of it, just kind of went through a little bit. Um, it's basically installing Windows Server and then kind of taking screenshots of it as you go along. Nothing too insane. So yeah, that concludes class 1 of week 1, chapter 1. I look forward to having you guys in uh, throughout the semester. The course is not too difficult. We do have 3 tests, but a lot of them are going to be like multiple choice, true, false. So just try to familiarize yourself with the terminology, and you guys should be fine. The labs are really just there for us to get hands-on practice throughout the semester with Windows Server. When you guys do work in corporate, it won't always be Windows Server 2019. It might be older versions, so you might lose certain features, but um, they the functionality across the software doesn't change that drastically, um, depending on how far you go back. So yeah, that concludes this class.